Hi, in this video we're going to see how to implement linear regression algorithm using Python. So to understand this use case, we will consider a public data set which is available in for a public usage, which is Boston housing price data set. So this data set contains a number of independent variables like what is the crime rate in this area, what is the zonal area, etc., etc., where we have our output column or our dependent variable which contains the median value of owners occupied homes in thousands, which means this data set is collected for the this historical data set contains the prices of a house, the average price of houses in a particular area based on the crime rate, zonal area, how much residential area is allocated, and how much industrial area is available in this particular town, whether these houses are in close to this Charles River or not, what is the percentage of nitric oxides concentration, etc., etc. Likewise, you can see the descriptions are mentioned in this data set, which also contains the tax values on how much tax is allocated and all those things, right? So we have this data set just to show you the glimpse of how the data set will look like, where this also contains the same observations as independent variables and dependent variable as MEDV. So sklearn is providing a library called datasets, where using these datasets which is available in sklearn for practice purposes, I'm going to import this Boston housing dataset from sklearn. So where I'm also trying to load linear model which contains the linear regression algorithm implementation, and I'm using metrics to evaluate the predictions that I'm going to get out of it. So I'm trying to import the libraries that I need, which also extracted the datasets as well. So using this dataset, I'm going to load the Boston pricing dataset. So which I will be able to see that I got my dataset. So if I just enter this Boston housing dataset, where you can see I'm using control enter to run this commands in my keyboard shortcut. So where you can see array of all my independent variables are been appearing here, and also my dependent variable is also here. So these are all my independent variables data, and my dependent variables are loaded into target. So to segregate this data, my independent and dependent variables, I'm trying to segregate or move my dependent variables into capital X as Boston node data, and also my dependent variable into y, small y, into my dataset. So after loading this, I just wanted to show you how our data will look like. This is how my data has been segregated. Now I'm using this sklearn model selection. I'm using this function called train underscore test underscore split, which can help us to split the data between testing and training. So as you can see, I'm using this test underscore train underscore split, which can help us to split the data between testing versus training. So I'm mentioning 0.3 as my percentage, which means 70% of the data will go for training data set, 30% of the data I'm choosing for my testing data set. So out of which, if I wanted to, I'm using this random state is equal to setting to number 1, which can be used to choose in case if I'm trying to split the data once again, where this random state is equal to 1 will help me to extract the same split out of this data. So if I wanted to extract different set of random split, I can just set it to random state is equal to some other number, where I can get the splitted data in a different way. So this random state is equal to 1 can help me to keep on extracting, keep on splitting the same training and testing data, whatever the times or whenever I run it, or whatever the number of times that I executed. This will help me to extract same set of training and splitting data in a same random split. So here, just to see how my independent variables will look like, and I can also see how my dependent variable will look like. Okay, so now I'm trying to create an object for my regression. So because this linear regression is available in this linear model, I'm trying to create an object for called regression for this linear regression algorithm. So this object can be used to fit or train my linear regression algorithm for the data set. So reg.fit can help us to train a model, and where I'll be providing what is my independent data and what is my dependent variable. So x underscore train will contain my independent variables, and y underscore train will contain my dependent variable. right? I'm trying to fit the model, out of which where you can see linear regression has fit the model, and where control underscore x true, and then intercept all the values it has considered the default values, and where I will also be able to see what is the coefficients which are generated. As you could see, reg is an object which contains my model, and I can also see the coefficients which are generated out of this. So based on each and every individual independent variable that I have used here, I can see that using for each and every independent variable, and this is the slope which is associated for this particular dimension. In the same way, I can also see the intercept which is created, which is 46.39 for this data. So this is how I can train a model. I can split the data between training and testing. I can train a model using linear regression algorithm using in Python. So if I wanted to predict an outcome for a testing data, so my linear model is ready for me, which we know that what are the intercepts and what are the slope associated with it. Now, if I wanted to predict the values for my testing data, like I can use this predict command, which I can pass my independent variables alone for my testing data, which will give us the predictions as an outcome. As you can see, y underscore prediction are the predictions that my model is able to generate for my testing data. These are the predictions that I can see that are generated out of my model. So now I want to keep both actual versus predicted data aside. So where you can see the actual versus the predicted data can be represented as a data frame, where you can see my actual versus predicted values are being printed over here. The actual value of this price of the house is 28.2k, where the predicted value is 32, and 23 is the actual value and 27 is the predicted value. Likewise, we can get actual versus predicted values. So if I wanted to understand, okay, if I wanted to understand how good the model is able to perform, I can actually see the difference between the average difference between actual versus predicted. That can also let us know what is the error term which is associated with this model. Or rather than looking at each and every individual object, to understand how good the algorithm is able to, how good this model is able to get the predictions, I can calculate the average value of y, based on which I can also understand what is the error term associated based on each and every prediction that I'm able to get. As you can see, 22.53 is the average value of y. So by looking at this average value of y, I can also understand, I can also calculate from metrics, I can also calculate what is the absolute error between testing versus predicted data. So I can calculate what is the average mean absolute error between all my testing data set versus my predicted data sets, where I'll be able to see what is the mean absolute error, mean squared error, and square root error, which you can see the mean absolute error is 3.34, mean squared error is 9.82, and root mean squared error is 4.45 by looking at the average mean of y value is 22. Similarly, I can also see my variance score as well, which is 78.36. So this is how we can implement linear regression algorithm for your given data, and also build a model out of it that can be used to predict your continuous variable as an outcome.